These are notes 4.2b, but again, side note, this is not in the textbook in section 4.2. So like normally if you need like another example or you want to like review something, you could go into the section, read where the book is talking about, see if it makes any sense to you. Okay, look at their examples. But if you go to section 4.2, you're not going to find any of the composition of functions. So what we talked about on Friday was polynomial operations, like can you add polynomials, combine like terms? Can you subtract polynomials, distribute your negative, combine like terms? Can you multiply polynomials, distribute all the terms, combine the like terms at the end? And we're going to do dividing polynomials tomorrow. But composition is not really a function operation, but it's something that we can do with two functions. And that is substitute one function in for x in another function. So normally when we've worked with functions in the past, like if we're thinking about graphing a function, we substitute values for x. Like we say, okay, well, we want to graph this polynomial. Let's find some points on the polynomial. So what if x is -2, -1, 0, 1, and 2? And we'll just like plug in that number and work it out and get a nice answer, right? It's the same idea with the composition, but instead of putting in a number, you put in a whole function, so it looks like an algebraic expression. Okay, so it looks like more x's with more things. Okay. Now there's a new notation, okay, that you're going to see. It looks like a lot of parentheses, so it's f open parenthesis g open parenthesis x close close. Okay. And this is how you read this: f of g of x. I like to write those things down when it's like the first time we've seen them, so that everybody feels comfortable when Ms. Cronky is talking really fast and says f of g of x. What is she saying? F of g of x. And what does it mean? That one means substitute g of x, a function, okay, so like whatever g of x is equal to, in for all x in f of x. So I often refer to g of x as the inside function, because in the f of g of x, it's trapped in all the parentheses. So the inside function is the one you sub in. The outside function is the one where you replace all the x's. So you kick out their x's and you drop a new function in. You can rewrite this notation any way you want. So we can also, other examples. We can also write things or see things like g of f of x. Then it's reverse. Plug f of x in for all the x's in your g of x function. We can write something that says g of x. So you can even use one function and plug the function into itself. Okay, so it's just saying, take your g of x and then replace all the x's in g of x with that same thing. Okay, so you're just like repeating the function. Okay. And as you progress in math, you could see things that have even more than one composition. So you could see like an f of g of h of x. Okay, so I could say, put h in for g, get a new function, then put that function in for f. We aren't going to, I don't think we have 3 to do, okay, but you could just continue this process. Okay, so we're going to do some examples. And we're going to use these 3 functions. So if you want to put these 3 functions like at the in your notes. Okay, we'll just be reusing these for our different examples. And if you look at your gold sheet, that's kind of like what your homework is. I give you some different functions, and then it asks you to do a whole bunch of compositions with them. And then there's a couple of book problems. So f of x is x squared minus 1. G of x is x minus 5. And h of x is 2x plus 3. So the first one we're going to do is, this one is pretty standard. You see it a lot, f of g of x. F of g of x. Okay, so my outside function, the one on the outside is f. That means this is the function that I'm plugging into. So where I see this x that's being squared, I'm going to replace it. I'm going to substitute in for that x. So kick out this x, drop in something else, square it minus 1. Okay? And then the inside function is what I'm going to put in. Okay? So my g of x is really x minus 5. Okay? So in function notation, I can write this. This is really f of x minus 5, isn't it? Just replacing, okay? And then, think about function notation. If this were f of 3, we would just replace all the x's with 3, but now it's just an expression. So we're going to replace this x with x minus 5. So we'll put in an x minus 5 quantity squared, and then a minus 1. Well, I could do a little bit of simplifying there. If I wanted to make it look like a polynomial in standard form, I'd have to expand x minus 5 squared. I probably wouldn't use our Pascal's triangle for that. That seems like more work than I need to. X minus 5 squared is just x minus 5 times x minus 5. So x minus 5 times x minus 5. And then at the end, I'll have a minus 1. If you take a minute, you should be able to just FOIL this out in your head. You're going to get x squared for your first term. And then you'll have a minus 5x minus 5x, so that's minus 10x. Plus 25 minus 1. So this is x squared minus 10x plus 24. Okay. So generally, if it looks something polynomial, you want to make it turn into the standard form where it has the highest exponent on the left and then decreasing order. Okay, so I've got, move this over so that I can, I'll move this whole slide in just a second. I can't ever find my thing anymore. Sorry, it's such a pain. Oh, there it is. Okay. So we got two more. We're going to do g of f of x, and then we're going to follow it up with an h of f of x, just for practice. Okay. So see if you feel comfortable. How would you sub in to g of f of x? Okay, so I'll roll it back up. You've got the functions at the top of your paper. See if you can make the substitution. Think about what's the outside function, what am I plugging into, and then what am I replacing x with? G of f of x. In function notation, that would just be g of x squared minus 1, which means take your x squared minus 1 and put it right where this x is, right? Replace the x, so we'll have x squared minus 1 minus 5. Now when I make the substitution, I do always protect it with parentheses, just in case I need them, I have them. Did I really need parentheses right there? No, there's nothing to distribute, it's not being squared. So it's really just x squared minus 1 minus 5, which is x squared minus 6. Thank you, AC. So this is g of f of x. Okay, that one was easy. Done. See if you can set up and evaluate h of f of x. H of x. So I'm going to substitute x squared minus 1 again. This time I'm going to put it into h. So that will be 2 times x squared minus 1 plus 3. Here, parentheses around my substitution was really important because all of it's getting multiplied by 2. So I would distribute, and that's a 2x squared plus 1. Done. Questions, concerns? Okay, now when might you use compositions? Well, it could be a case of like, let's say you're studying something and you have, let's say you're getting temperatures in Fahrenheit, you need to change them into Celsius, and then you're going to do some other kind of calculation with the temperature for some reason. Well, instead of having to do it manually twice, like change it into Celsius and then plug it into this thing, if you just took your functions that you had and made the composition in terms of x, then you would just have a new function that would do all of that. It would change you into Celsius and do the work in the other formula for you. So like an example could be like, like forensic medicine, like body temperature. They can calculate like the time of death, okay, based on the temperature when they find the body. So, it depends on how it's being reported or what form it needs to be in, and then you could do all of that in one, and that would save you time if you had to keep using that function. You'll see a lot of examples in textbooks and things that have to do with discounts at a store. So, if you're a big shopper or online shopper, you might notice this in your cart. Like if you get a % off and then you have a $10 off, which one is the store going to do first? They're going to take off your money, like the $10 first, lower your total, and then take a %, because then the % they're taking off is less. So it's good for them. They're making more money. Okay? So those would be times when you might see a composition in the real world. Okay? Your homework, this is on your gold sheet, okay? So you can find the 3 functions. Okay. Did I use the same ones? Yes, I did. No, are they different? Oh, they're reordered. Maybe. Oh. Yeah. Sorry about that. I didn't know that. You're going to do those 5 compositions, and then notice this is from the textbook. I know 47 is another one, practice Pascal's, and then 65 is such a good, thinker question. Really read that and try to come up with a plan to solve. So you could probably get quite a bit of that done here in class.